SN2 reactions are nucleophilic substitution reactions of the second order, and the order is of rate law, second order rate law. Here are the general form of SN2 reactions. A nucleophile reacts with a carbon with an appropriate leaving group. The nucleophile stays, the leaving group takes the extra electrons with it and becomes whatever it is. It could be an ion, it could be a water, it could be a whole lot of things. So a good example to show what's going on, so there's more to it than that, is hydroxide reacting with methyl iodine. Hydroxide is a strong nucleophile. It's going to attack the backside of this carbon. Now what's important for an SN2 reaction is that there be a good leaving group, something that's polarizable, because what's happening in this reaction is a nucleophile is going to be attracted to a nucleus or a positive charge. In a situation like this, an iodine is very good at withdrawing electrons from whatever it's bonded to. It's a halogen. So this will have a partial negative and this will have a partial positive. The nucleophile is going to be attracted to the backside of the carbon where there is a partial positive charge. Here, the transition state, the electrons of this hydroxide are now going to the carbon. So now this iodine is having an easier time pulling the remainder of those electrons away from the carbon, and in the end there's a hydroxide and it takes those extra electrons with it. Now you could spend all day talking about SN2 reactions. There are going to be a lot of competing reactions, but the most important things to look for when dealing with SN2 reactions are the nucleophile strength, the leaving group, is it a good leaving group, and one more thing, the stereochemistry. I drew one more example here of iodine, but instead of hydrogens with methyl groups. And if we have a look here, it's nearly the same. The same thing is happening here. The iodine is withdrawing electrons. There's going to be a partial positive and a partial negative. But this hydroxide isn't going to be able to get to the backside of this carbon because it's blocked by all this stuff. There's steric interference. So that has a lot to do with SN2 reactions as well. The less interference there is, the more quickly a reaction is going to take place. Because when there are competing reactions, often more than one reaction is possible. And then it really comes down to which one is quickest. One might be many, many times faster, and so much faster that the other one never really takes place. So the more steric interference there is, the slower this will occur. With three like these, it's basically never going to happen. If there are two, then it will happen, but a lot slower. If there's one, it will happen at quite a brisk pace. But if it's competing with something else, that might be enough interference for this reaction to not be a major theme in whatever's going on. So it's just something that is very important for these type of reactions. Strength of the nucleophile, the type of leaving group. If it's not a very good leaving group, it might slow down the reaction and give other reactions a chance to take place before this. What kind of leaving group there is, and then lastly, what kind of steric interference there is. Nucleophile, leaving group, steric interference.